Okay, so you are in You Learn, then go to week 9. We are in week 9 right now. So manually take your attendance, right? And then we are in the synchronous class right now. And then towards the end of the class, you're going to do as usual the reflection. Reflection will be open. I will open it at 9:50 a.m. Okay. So sorry. So let me share my slide. Okay, that's it. Okay. Everybody, are you in? 24 student. Okay. So I will just start. Okay. For as mentioned in the Telegram group. Okay. I'm going to do a revision because since next week is the midterm exam, so and then you just have had your semester break last week, so I think maybe your mood is still raya lagi lah. Okay, so and by the way, selamat hari raya to all the Muslim. Okay, maaf zahir batin. Okay, so therefore, for today is that we are going to do a revision of preparation for midterm exam, which is a very fast revision on chapter 1 and chapter 2. So bear in mind that for can you hear me? Boleh tak? Sebab tak ada feedback ada okay dengar Okay, bear in mind that I will be making a summary for each chapter. Means that very quick one because as you know that we already finished chapter 3. So you might forgot about what you have learned in chapter 1 and chapter 2 because it was done in the earlier part of the semester. So okay, let's just look at the slide. Okay, so as a recap is that for chapter 1, what you've learned is on the signal system, types of signal system, and then there are 2 types of signal that you have learned. Okay, remember that 2 types of signal, which is the continuous time signal, and then you have also the discrete time signal. So how do you know that it's a continuous time? Or how do you know that it is a discrete time if you are given an equation? Okay, so remember, always remember. Okay, there are 2 indicators. How you how to identify it's a continuous time or discrete time. The first one is the value, denotes of the value, t and n. So if you see that there's a t value and a normal bracket there, so that one will be the continuous time signal. Okay, so always remember that. Okay, because why I emphasize this is that I always see students making the same mistakes every batch. Okay, every batch there will be some student making the same mistake, wrongly identify the signal. Means that you're given actually the signal is in a continuous time signal. Okay, but when student do calculation for convolution, they do it in the convolution sum, which is in the discrete time signal. Okay, which is totally wrong. Then you get 0 marks. Okay, so please make sure that do a revision before class. Go through all the notes, all the videos, the class, synchronous class videos, and do revision. Okay, even though I know that, and you know that the midterm will be open book. Okay, open book means that because this is what I worry about student. They think that it's open book. It means that everything they can refer to during the exam. Okay, actually, lecturer are not going to recycle the same question during class tutorial or midterm exam the past year's example. No, we are not going to recycle that. It's a new type of signal. New type means that different signal lah. Maybe the same concept but different signal. So if you are not familiar with it, you didn't do a revision and all, just assume that it's going to be easy because you can refer to notes. Then you are wrong. So make sure that please study. Go through chapter 1 and 2 notes and go to the video to actually recall back what you have learned. And you have actually submitted lots of tasks that are given to you from week 1 until week 8. Okay, task means that task in Padlet. Okay, you can go through the Padlet and look at tasks that was given to you, and for those who have uploaded, then there's a bonus point for you because you actually did the derivation, okay, and get the answer. For those who did not do the calculation, you didn't answer the question lah, basically, and you didn't upload to Padlet, or even you didn't submit the assignment given, then that will be a loss for these students. Because why? You didn't practice. Okay? Bear in mind, signal system, lot of mathematical equation. If you don't practice, you cannot answer it. Okay? So, again, I'm emphasizing on identifying the different types of signal. So, you have the continuous time signal, which is denoted by T. And then we have the discrete time signal, is denoted by N. And you know that how it's being identified is the square bracket. Okay, so there are two indications how to identify the different signal. Okay, continuous time is in terms of the normal bracket, and the discrete time is in terms of the square bracket. Okay, totally different. Okay, and this one is announcement. I don't want student later on SMS, not SMS lah. Send me telegram message privately or even email to me saying that, Doctor, I thought the midterm exam was on Thursday, hari Khamis, Thursday, 9 p.m. So I didn't attend the exam on Tuesday. Oh, sorry about that. There's not going to be any repeated test. Okay, I actually reminded. Okay, because reason why I want to remind again student, because there was some subject that happened like this. Okay, and sorry, but I'm going to tell this. Foreign student always do this type of problem lah. Foreign student. So don't do that. Okay, I hope my student, the student in this class is not going to do that type of excuses. So we are going to have a midterm exam on 25 May. Okay, on Tuesday. Okay, dalam bahasa Melayunya hari Selasa 25 Mei. Okay, Selasa minggu depan. Okay, next week on Tuesday 25 May. Right, and exam time will be at night. Don't get confused pula. AM and PM, you don't understand what is different between AM and PM, because some student exam time pun confused. Okay, exam time you get confused. Is it AM or PM? Okay, make sure that you know the exam is in the morning or afternoon. Okay, so our exam is at night, 8 p.m. Okay, no excuses, fall asleep and so on. Make sure you don't fall asleep. Okay, and you have roughly about how many days? About 4 or 5 days before the midterm exam. Make sure that take care of your health. Okay, don't study late and so on, because if study late, then you will actually, chances that you get a fever or not feeling well on the day of the exam is high. Okay, and as you know, COVID pandemic. Okay, right now for UTEM staff, we need to work from home. Okay, and I'm not sure about you guys. Are you in the UTEM or at home? So anyway, take care of your health. The number of cases is already reached 6,000. Okay. Can I know, is anyone listening? Can you write that in the chat, because I think it's too silent. Write there in the chat. I'm listening. Thank you. Okay, right. Thank you. So you are there, all right. So I'm going to continue. So make sure that you know that the exam, okay, in Telegram, I mentioned that the exam hour is 1 hour, but after looking at the question and then also the solution, so we decided, the lecturer, we have discussed, we decided that it's going to be 1.5 hours. Okay, so we will start at 8 p.m. Okay, 8 p.m. 8 and we end at 9:30 p.m. sharp. Okay, where the location is using my ULearn. Okay, means that you're already in my ULearn, so no problem. Okay, for other sections, section 2 and 3, section 2 is under Dr. Faid and section 3 is under Dr. Ain. The student need to enter my ULearn. Okay, so if you have friends taking signal system, BEKM, BEKG, please make sure that inform them, enter Dr. Mariam ULearn before the midterm exam. I have made announcement that students should enter before 7 May. Pass already, yeah. So hopefully by now, everybody, 117 student is already in my ULearn. Yeah. And the chapter covered is chapter 1 and 2. Okay, I'm not going to give any tips what type of question is going to go out. Is it continuous time? Is it discrete time? No. Because it's open book, then you're going to study all. Eh? There's no tips from me. Normally, I don't give tips. So before the exam, just to ensure that student understood what to do. Okay, because sometimes student suddenly on the day of exam don't know how to submit the answer script and so on. So I'm going to go do a briefing at 7:50 p.m. which is 10 minutes before. Okay, but I'm going to open earlier than that. Okay, 7:50 p.m. sharp. I'm going to do the briefing. Okay, no delays because we will start at 8 p.m. So it's like a normal exam lah. Okay, at normal exam, the invigilator, the lecturer will brief student, okay, what you need to do, blah, 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 blah. Okay, 9 p.m. sharp, okay, is the deadline to upload. Means that don't 9:30 p.m. you want to scan your answer. No, please make sure that you scan earlier. 9:30 p.m. is the due date. Due date. Okay, the last to submit. Right? Means that 1.5 hour including you scan your answer script and upload it, including that. No additional time will be given for scanning. All right? You already have been through the online exam 3 semesters, so I think by now you know how to scan a paper and upload it fast. Right? So the briefing will be via MS Team. I already give you the link there, and I also make the link here, okay, or to click on the link directly, you can go to my ULearn. Okay, the ULearn under announcement, I have made announcement. So click on that. You can click on the MS Team link in ULearn. Okay, can you see that? This link. Okay, I think you know, right? If you move your cursor, when it moves somewhere and there's a hand pop up, means that there's a link there. Okay, just in case lah, some student don't know. Alright, so let's go to the recap of the subject. Okay, so in chapter 1 is that what you have learned is that you have learned 2 types of signal, which is the continuous time and discrete time. Alright, and then in the chapter 1 you have learned about 2 types of transformation. You have first one is time transformation and second one is amplitude transformation. Right, amplitude transformation. So for time transformation, you have the time shift, time reversal, and scaling. And same goes to amplitude transformation. You have the shifting. You have the scaling. And you have the reversal. Okay. And what else? Okay. And for the time transformation, you have learned there are 2 methods. Right? 2 methods. You have method 1 and method 2. Okay, I'm going to do a summary so that, okay, you recap again what you have learned. So there are 2 methods for time transformation, method 1 and method 2. For amplitude transformation, only one method. Okay? If you forget, then go again to watch the video. Okay? And next is what you have learned is that you have learned about periodic signal. So periodic signal is that you have learned about two types of signal, which is the odd signal and the even signal. Okay? And you have learned that odd plus even signal, you will get the original signal. Okay? Oh, which is this one. Okay. So let's just do a very quick one. So I will just pick up a few examples that you have learned. So remember last time, you did some exercises. So you are given a signal xt over here. And then in the question is that find yt x1 minus t minus 2. So there are two methods how to answer this, right? So two methods. You have method number 1 and method number 2. Okay? So method 1 and method 2. Okay? So just very quick one. So method 1, how you do method 1 is that always shift it first. So before you do that, okay, identify first. Okay, if you're given the signal, imagine that you're given xt, find yt, x1 minus yt. So first, what you need to do always for subject signal system is identify first. What signal is it? Okay, is it a continuous time signal or is it a discrete time signal? So just go and find, is there a t value or n value? So you see that there's a t value, wow, that's that actually a continuous time. So as if you know that there's a continuous time, then the graph should be always connected. Okay, for discrete time is that the graph will be a pulse type. So continuous time, so we are going to do the continuous time. Okay, and then the question is find yt. Okay, by referring to the signal x. So you see that there's x here. So which is this x. Okay, 1 minus t over 2. Okay, so what you need to do here is that what you need to do first, rearrange again the signal so that it's easier for you to actually do the transformation. So rearrange it so that the t value is in front. Okay? So x minus t over 2 plus 1. Okay? So only then you can see, oh, okay, now I know. Now it's clear that there are time transformation. Is there any amplitude transformation inside here? Can you write that in the chat? Is there any amplitude transformation in the chat? Yes or no? Okay, good. Okay, everybody answer no. So there are no amplitude transformation. Why? Okay. Okay. First, how to identify that either it's the time transformation or amplitude transformation is that look at the value. You have yt here. Okay. You have yt. The question is that find x something and in the bracket, right? Okay. So you have the bracket back here. So whatever in the bracket after x will be a time transformation. Time transformation. So you know that everything will be a time transformation. You will know that it's like you have a amplitude transformation if we have something in front of the x here. If there is a value in front of the x, then it's plus amplitude transformation, or after this value you have plus here something, then you have amplitude transformation. Okay, so for this type of question is only time transformation. Okay, and after you identify that there's time transformation, then you know that time transformation, there are three types of transformation. The first one is shifting. Second one is scaling. The third one is reversal. Okay, so from here, you need to identify which is which. Okay, okay. So if you are using method 1, I always tell students use only method 1. Don't go and use method 2. Method 2, you need to rearrange everything and so on, and it will be a bit difficult, but still the answer is correct. Okay, but the easiest way is that use method 1. Okay, method 1, directly you can use this equation to answer. Okay, you have the minus t over 2. You know that everything with the t value here, minus t over 2 will be the scaling factor. This is the scaling factor. Okay? And then for shifting, you know that it's a time shift, advance or delay if you have plus or minus over here. Okay? So this is how you know. And another indicator that you have a reversal is that when you have a minus here at the scaling factor. So you know that there's a reversal. So for this question is that you have all the three transformation. You have the shifting, plus 1 is actually advanced. Okay. And then you have the scaling. Scaling is 1 over 2. So 1 over 2. Okay. 1 over 2. Scaling. Remember, the easiest way how to understand about scaling is that you have a tape recorder or a video. A YouTube video that you run at the speed of half of it. So what does it mean? It means that this signal will be shortened by half. Okay, instead of minus 1 to 2, it will become from minus 0.5 to 1. Okay, it will be shortened by half. Okay, right? And then it will be reversed by 1, by minus 1, so it's going to be flipped. So you have done that. Sorry. Oh, sorry. Not shorten, Saja testing. Okay, testing you guys. Okay, 1 over 2 means that your scaling factor means that the video will be at the speed of 1 over 2. Means that slower speed. Okay, kalau twice is going to be faster. So ni is going to be slower. So this one is slower. This is faster. Okay, so it will be double lah. 2 times 2, 4 and minus 2. Right? So this is how you know that it's going to be expand or compress. So the easiest way is that 2 times lah. Normally, if you watch a YouTube video, you watch a YouTube video. Okay, let me show you example. YouTube. Okay, example. This one is YouTube video. Okay. If I were to run it twice the speed. Kejap kat mana? Boleh? Okay. Okay, you see that normally, sorry, I see here is that play normal speed, right? So if I play it at twice the speed, you see that I'm talking very fast. Okay, very fast. So this is how you know that the video is actually compressed. So if you do again, okay, make sure that you do again what all the exercise that given, then you will actually recap again, revise again what you have learned. So this is using method 1, you get this answer, and using method 2, you get this answer. Okay, same thing. Method 1, directly use the equation. No need to actually organize it. Method 2 is that you need to reorganize this equation. Okay, how you organize is that you need to leave the t there. Okay, so take it out, the scaling factor. So minus of 1 over 2, minus 2. So, and then only you do the scaling first. Okay, scaling is 1 by 2. So meaning that you're going to expand it by times 2. Okay. And then you do the reversal. Then only lastly is the shifting. So method 2, the shifting will always be the last. Okay. But I would say that you need to do an additional step, which is this one. So sometimes you might make mistake at this part. So might as well you use method 1 directly. Okay, and then what you have learned is also amplitude transformation. So if you have this signal, okay, and what if you're given a block diagram like this? Okay, a block diagram given example, if this was not given, okay, I'm only giving you yt over here. All right, imagine that there's no value here. Okay, and then I'm giving you the signal xt, which is signal xt refer to this signal. And there's a gain value, 3, gain value 3. Sometimes in exam, you're not given a value directly here. It's given by example A, okay, or B and C. So in the description, the sentences, you will say that the gain for A is 2, example. So what you need to do is that substitute only lah, 2. So what normally for this type of question is that you need to actually come up with the equation, yt. Okay, so don't panic when you get this type of question. So just write out the equation. So first, try to write out this first block. So you know that you have example, we are using the original example. So you have the gain 3 over here. Okay, so what you have here is the output of this block, right? So you have 3, the gain 3xt. Okay, 3xt. So if you see this 3xt means that just now I already explained how to identify if it has a time transformation or amplitude transformation. So if you have a time transformation, normally you have xt minus or plus something over here. So you know that this is a time transformation. But for amplitude transformation is that everything before this x value. So you have a 3 value, 3 gain here. So this is amplitude transformation, which is specifically is scaling factor lah. Okay, scaling of the amplitude. Okay, so you can write it as the signal at this part is 3x3, 3xt. And then you have the summation point over here, means that you have plus and plus over here again. So this is very simple. So yt, the signal at this point is 3xt minus, since you have plus, but the signal going into this summation point is -1. So -1. So you get 3xt minus 1. So therefore, for this type of signal, you have actually a amplitude transformation, okay, which is gain. Okay? And then you have also the shifting, amplitude shifting by -1. Okay? So this was the example that we did in class. So based on the signal, you did the amplitude scaling. Okay, for the amplitude scaling, it's actually according to the equation. So it's like a mathematical equation. So what you need to do is that settle first inside here. So 3xt means that whatever you have xt over here, multiply the amplitude or the gain amplitude by 3. Gain 3. And after that, only you do the shifting. Okay, so that's why you are doing the amplitude scaling first. Next, you are doing the amplitude shifting. Okay, scaling, just multiply it by 3 lah, 3 over here. Okay, and then shifting it by 1, so means that everything, this signal is going to be shifted by 1, -1. Okay. And this one was some of the exercise that you did also. So you're given this xt, and then you need to plot yt 3x1 over 1 minus t over 2 minus 1. Okay, if you see this type of signal, don't get, oh, why the signal is like this? No, you just write it again, t1 minus 0.5t. So actually, this signal and this signal is the same. Okay, so don't get panic when you get any question. So 3x 1 minus 0.5t minus 1. So you need to rearrange again this signal lah. 3x minus 0.5t plus 1 minus 1. Okay, then you can do from here, you know that, oh, okay, I have the time transformation because everything is in the x value bracket here. This is time transformation. And then you have the amplitude transformation, 3n minus 1. Okay, so recap on that. And then we did all the exercises. So later you go back and do the revision. Okay, the last, and then next we went and discussed about the periodic signal. So periodic signal is something that when it have a fundamental period t naught. Okay, means that it's going to repeat 0 to t and then repeat and repeat and repeat. So repeating signal. One signal is repeating until infinity, you will call it as a periodic signal. Okay. And of course, if you look at this type of signal, okay, you know that okay, if you look at this signal, okay, if you will not mention that this is either continuous time or discrete time. So if you look at the signal directly, you know, oh, okay, this is a continuous time. Why? Because you have a t over here. You have t and you have a bracket. So it's directly a continuous time signal. Okay. So, and vice versa, you also can have the same signal in discrete time. So discrete time is labeled as x n. Okay? And difference between continuous and discrete is that continuous, you see that the signal is connected to each other. For discrete time, it is represented as pulses, okay, at an interval value. Okay, the interval value is 1. You don't have, for discrete time, for the case of discrete time signal, the value cannot be written as 4.5, 4.6. No, there's no such thing, you plot it in this term, okay, unless you're doing sampling. But for these cases, for discrete time, the interval is 1. So 1 means that 0, 1, 2, 3, and so on. Okay. So this is an example of discrete time. And normally I would suggest when you draw out a discrete time, label directly the amplitude. Okay. For the case of like this. Okay. You have at 0, you have the amplitude at 1. So 1. And this one is minus 1, minus 1. Because later when you do, for example, convolution sum, okay, or some other calculation, you can directly use the amplitude, okay, without mistaking. Okay, so, and then after that, what you have learned is on the even and odd signal. Okay, so even signal means that it's a symmetrical signal. Symmetrical signal means that if you have a signal, okay, xt like this, you know that it's symmetrical when when you fold it together at a t equal to 0 here, it will overlap perfectly. So this is what it means by symmetrical signal. So you have the value of x minus n equal to xn, means that the amplitude is the same, just that it's reversed on the t equal to 0. Okay. And for the odd signal is that it's anti-symmetrical. Okay. Means that if you actually fold it, it's not going to overlap. Okay. But it's going to overlap for the second fold at the this value y-axis. Okay, so therefore you can see that the equation given by x minus n equal to n minus xn. So example of even symmetrical is cosine wave. Okay, cosine wave is a even signal. odd signal is sine wave. It starts at 0. So you have the odd for sine wave. Yeah. Okay, and after that, you have also learned how to actually derive. So find, for example, find XE, the even even item for the signal. So XE is given by XT, so the original signal, okay, plus X minus T. So means that you need to reverse the original signal X at the minus T. So when you look at this, okay, minus T is what? Time reversal. So just reverse it, time reversal, and divide by 2. Okay. And vice versa for the odd signal is that you have xt minus. Okay. For even you have plus, for odd you have minus. Minus x minus t over 2. Okay. So the difference for even and odd, the equation is at the symbol. Okay. This mathematical symbol. Plus minus. Okay. And lastly is that you can express any signal by the combination of even and odd. So you can get back the original signal xt equivalent to x even plus x odd. Okay, so if you look at this, okay, this part will be the continuous time signal. Okay, why? Because it's t denoted by t in bracket. And for this is the discrete time signal because it's denoted by n in square bracket. Okay, so equation is the same, just that it is different how it is being represented. Okay, xn in square bracket equivalent to xe plus x0. Right? So you did some exercises where you actually prove the equation. You are given signal xt. You're given odd. Yeah, sorry. You're given. You need to find what is the even equation, and then what is the odd signal. You draw it out, then you prove that the signal is given by xt equivalent to x even plus x odd. Okay, so we did some exercises. Okay, you can refer back to the video. So what you did was you actually prove the equation from the xt here. Okay, so you draw out first what is the xt. You have xt here, xt, so you draw out xt. Then you draw out x minus t, so x minus t. Then, because for the even is that you have a plus sign here, so you add it. So what you add is this one. Okay. And because, okay, if you look at the original equation, you have xe equivalent to xt plus x minus t. Okay. So you have 2 over here. So if 2 over here, you bring it up here. So you have 2 xe. So that's why you have 2 xe over here. Okay, so 2 xe equivalent to xt, this signal, and x minus t is this signal. Okay, so since you have the 2 value here, that's why you need to divide the amplitude later on by 2. By gain 2, yeah? So don't forget that. So that's why the final answer is this. Okay, so because the amplitude is 2, you divide by the 2, gain 2, yeah? Right, and in vice versa, for the odd question is the same, just that instead of having the plus, you have the minus here. So you are going to substitute the amplitude. Then you get 2x naught, and then you divide the gain by 2. Then finally you get this answer. And lastly is that you prove the signal. So prove that xt equivalent to x even plus x odd. Okay, so you add the 2 signal, then you get xt back. Okay, the origin signal was this, so you get the signal. So don't forget, when you do this, please make sure that label the amplitude. Yeah, okay, label the amplitude. Okay. Next, we did on the exponential. Okay, very fast lah. Okay, and then you learn about how to draw out an equation, draw out the signal based on equation. Okay, you have a unit step. So when you have un means that you have a unit step until infinity. Step until infinity with amplitude 1. So because it's un, then you know that it's a discrete time. Okay, if it's ut, then you know it's a continuous time. So ut, how do you draw it? Ut is like this. 1. Okay, for discrete time, it's like this. This is discrete time. Okay, so don't get confused. So the difference is that by the symbol and the bracket. And then you have learned also for delta. Okay, un and delta, don't get confused. Un is a unit step, means that it's like a step, your staircase lah kan, staircase. You step up by 1. Only staircase to 1 saja naik. Okay. For discrete, for the impulse is an impulse. You bagi one impulse only. So the impulse is at 0. So you have delta n here. Okay. And if you see that there's a delta n minus a value, okay, then for example, delta n minus 10 means that it's a delta. You know that, oh, okay, it's an amplitude delta shifted by 10 to the right. So this is 10. Okay, so you have this signal for delta n minus 10. Yeah. Next, you learn about, okay, you learn about the multiplication. Okay, multiplication of two signal. You have delta, you have xn multiplied by delta n. So you will get only one signal lah, multiple sampling lah. This is what we call as sampling. Okay, don't confuse with convolution sum. Okay, the convolution sum and integral is actually for linear time invariant. Okay. Okay, unit step. This is for this continuous time. So unit step ut just now. Unit impulse is like this. It's similar like the discrete time, just that for impulse, you're going to use the arrow going up. And then you have the RAM value. Okay, RAM value. You have for t more than, so basically, RAM value is written with TUT lah. Okay, if you look at this, actually you have two components over here. Here UT is the signal and then T is the RAM. Okay, T is the RAM value. So T, how do you find T is by using this equation. Okay, y equal to mx plus c. So we have the value of m. You know that for this case is that m is the slope is 1. So you have the t value plus c. C is the cross section at y. So because it's 0, then you have y is equivalent to t only. Okay, so this is the t value. Sometimes the t value might be 2t. Example, might be 2t. Means that the slope will be like this. Okay, so it depends. How you find the t value is by using this equation. Okay, and this one is a very short example how to find transfer function. You are given signal, find the transfer function. So if you look at this, you know that, oh, okay, I'm going to write the transfer function in continuous time. Okay, and since you see that, oh, it's a square signal, then you know that it should be a unit step. Okay, combination of unit step, ut. Okay, with a shifting value. Okay, so that's why when you do this, you have ut minus 1 is shifted by 1 minus ut minus 2. Okay, so do that example later. Just recap again. So you did all of this example, implied it, and even you submit. So try to answer. Okay, and for example, I'm going to look at the example D. Okay, D also you did the equation, the exercise. So you have, if you look at this, okay, let's look at it together. Xt equivalent 3xt, first equation. How do you know that's the first equation? Because the next that you see is a plus symbol. So that's where you can differentiate that is one equation. Second one is the TUT, second equation. Next, you have the minus. So this whole thing will be the third equation. Okay. And then what else? You have minus. So you have another equation is at this value. Okay. So meaning that for this example is that you have four equation. You need to draw out four signal lah. Okay. Compared to this is only one. B, you only have 1, 2. And then after doing the substitute the value, then you multiply it by 0.5, which is, if you look at this is combination of time transformation, which is time delay, and then you have a time scaling, 0.5. Okay. So all of these are reflecting to what you have learned in the time transformation, amplitude transformation. Okay. And next, you did this example, midterm example of exercises. Okay, past year punya. I'm not saying that it's going to be same. No, not the same. But at least you know how difficult it will be. Yeah. So you are given this. So find out the singularity function. Singularity function means that the equation lah. Find the equation means that instead of you drawing out this equation, you need to find this equation. Okay. And I hope that everybody did all the tutorial session that was given here. Okay. In these exercises is that you were given the exercises in continuous time signal. Okay. For example, sketch the waveform xt 3 ut minus plus 1 minus 3t blah 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 and so on. You have 7 exercises. And bear in mind, actually, the same equation here can be written also in discrete time. Okay. For example, let's look at this first one. Okay, I wrote here plot in discrete time. Not plot sorry. Write Write in discrete time. So if I were to write this equation in discrete time, how does it look like? It's going to look like this. X n equivalent to 3 u n plus 3 minus u n plus 3 u n minus 3 plus u n minus 6. Okay, so this is how it looks like. Means that in your exam, sometimes it doesn't mean that you are given a continuous time. Okay, waveform continuous time is an equation, then plot the waveform. Sometimes you're given discrete time like this. So you need to plot the waveform. Okay, when you plot the waveform means that you need to plot it in terms of like this lah. Okay. Okay, for example lah, if I were to take this exercise D, so you have 3n, 3un, this one I already convert to discrete time. Okay, 3un plus nun minus nu minus 1, un minus 1 minus 5un minus 2. Okay, means that if I were to write 3un, okay, this signal will become something like this: 0, 1, 2, 3. With the amplitude 3. Okay, so the rest will be 0. This one is infinity. So it's actually referring to this. Okay, but in terms of the discrete time. And then when you have nun, so nun, the signal will become 0. This signal, this signal over here. So you have, this is 1, 2, 3. Okay, until infinity because it's nun. Okay. And then the next signal is n minus 1, un minus 1. So it's actually the signal un minus 1 okay, shifted at 1, okay, and because you have n minus 1, this means that you have a slope like this, okay, means that it's minus 1 actually cross like this, kan? But since it's actually a discrete time, so you cannot write it like that, right? So you need to draw it like this. Okay, I think I have shown to you the example 0, 1. Sorry, that one is wrong. Okay, so you will have something like this. Okay, so 1, 2, 3. 1, 2, 3. It representing this signal. This signal. But bear in mind it's negative, so it means that you actually need to flip it, okay, at the minus value, okay, minus 1, okay, minus n minus 1, okay, so it means that it's going to be this one is going to be like this. Instead, cancel out later on, okay. So you get the idea lah, So each of these equation can be actually written in terms of discrete time. Even though in the class I didn't actually focus much on the discrete time example, but now I'm telling you that you can write it also in the discrete time. Okay, should be student understood that. Okay, u n minus 2 and so on, right? Okay, then we did some exercises, okay, like this. And then we did a midterm example format. Okay, for this case is that you were not given any waveform, but you need to draw out the signal Gn. After doing the draw out the signal Gn, then you need to apply transformation. Okay, this one is direct. And okay, the last part that in chapter 1 is that you did on the interconnected block diagram. Okay, the gain value. For this case, chapter 1, you learn about the gain value. So it means that the T is actually a gain, 1, 2, 3, and so on. Okay, so if you have a summing junction, how you should add it, product, how you should add it, and so on. Okay, and we also discuss about the cascade block diagram, the gain value lah. For example, this one is gain value 1, 2, and 1. So how do you actually find out the gain factor T? So T, you can derive it and you get it, T equal to T1 plus T2. And for the parallel is that when you derive it, these two cascade and series don't memorize. Please don't memorize. You need to understand how to get this. Okay, how do you get this value T? So T is, derive it on your own, you can get T equal to T1 plus T2. The reason why you need to derive it on your own, because each step, each of these have marks. You might think that, oh, only this one might have marks. No, this one have marks, 1 mark, 1 mark, 1 mark, 1 mark. If you only answer this one, and it's correct, okay, fine, you will get 1 mark, but you will lose 3 marks in terms of the steps. Okay, so don't skip. Okay, even though I know some of you are very bright in terms of skipping all the calculation, directly give the final answer. But however, sometimes giving out the final answer indicates that you are actually copying from your friends. Okay, so in order for lecturer to see that, oh, actually you did all of the steps and get the answer, is that you need to show the steps. And then finally we did one example on if you're given a block diagram like this with a different gain value, then how do you get the signal YT in terms of XT? Okay, so meaning that for example, find the total signal output, so YT. So you need to get YT if equivalent to TXT. So what is this T value? So you have learned that t value, when you derive everything, you can get the value for the gain if you were given the gain value. Okay. All right. So that one is the revision for chapter 1. Any question before we take a break? Any question? In the chat? Any question? Hello? No, eh? Okay. Okay. No, if no question, then we take 10 minutes break. We come back at 9:10, eh? All right. Thank you. Okay, right. So, okay, everybody in. So let's continue for the revision chapter 2 eh. Okay, hello. Boleh dengar? Can you hear me? Right. So, just to recap those who came late. Okay, we have a midterm exam test next week, 25 May. And it will be at 8 p.m. 8 p.m. means at night, eh? At night, 8 p.m. until 9:30, which is we have 1 hour. We are giving you 1 hour, 1.5 hour. Location will be at Yulen, my Yulen. So those who are in already Yulen, then should be no problem. For student later on, just take note lah. Okay. I already in my Yulen, I have informed about the midterm test. Okay, and as you know that there will be a briefing 10 minutes before. Okay, for all students, means that section 1, 2, and 3. Okay, 10 minutes before, and the briefing will be at 7:50. The link here, you can access it at Yulen, so you can click on this midterm exam, open that, and then you can go to this link. Okay, right. And for the midterm exam test, I will actually open put the exam maybe at down here. Okay, midterm exam, another block over here for midterm test. Okay, so for student, you need to access here. So during the briefing, I will actually brief lah where you need to enter and so on. So and for your information is that, okay, those who plan to copy, cheat, okay, copy, plagiarize, or cheat, or submit to check or whatever, okay, you don't do that because you have multiple sets of questions. The question sets is more than 10. I'm not going to give you how many sets, but it's more than 10. It might be 30, it might be 40, okay? It might be 50, 50, okay? So, so don't cheat lah, okay? This is where we are going to test student on the concept, okay? All of what you have learned during chapter 1 and chapter 2. So do not cheat, okay? Do not discuss with your friend. Just focus doing your answer, your solution. Yeah? And bear in mind, this 1.5 hour is actually enough for student to answer. Means that those who are very good students, they already did exercises and so on, they can finish it within 1 hour. Okay? Normal student who didn't do the revision, just maybe one time do some revision, do all it one time only. Okay, you didn't do multiple times, twice or more than that. You didn't practice more than once. So you might require more than 1 hour, 1.5 hour. Okay, so this is where we are going to differentiate between good students, good grade students, and lower grade students. So I hope that this one is a tip lah. If you want to get good grades, then you need to practice a lot. Okay. Okay, so let's go to chapter 2 revision. So what you have learned is on the linear time invariant, but for this, I'm going to focus on the two main thing, which is on convolution and sum and integral. So when we talk about convolution sum, okay, it's always for the discrete time signal. Okay, and for the convolution integral, it's on the continuous time signal. So it means that when you were given an equation and it's in terms of n in square bracket, then you know that you need to do a convolution sum. And if you were given t in a normal bracket, then you need to do the convolution integral over here. Okay, so don't mix it. Okay, if you were given the signal in terms of t, but you did a convolution sum, directly 0 marks. Wrong concept already, 0 marks. It's totally wrong because the convolution sum and integral is different equation. So this is, I emphasize again, make sure that you amplify that it's the correct signal. Is it a discrete time or a continuous time? Yeah. Okay, so for convolution sum is that we go first for convolution sum. So directly you see that, oh, okay, it's Sn in square bracket. So you know that you're going to do convolution sum. Okay, and normally when we have this type of signal is that you have a signal in a block. So we call it as Hn impulse response. And might be that you have an input Xn value, another signal. So it might ask you, okay, find the convolution sum Yn equivalent to Xn star Hn. Sometimes it doesn't mention that it doesn't mention, oh, use convolution sum. No, it just asks you to find the convolution for Yn. Okay, so when you have that type of question, you know that you need to do a convolution. So you need to pick up which one. Is it convolution sum or convolution integral? Okay, so for this case is that you need to do convolution sum. So convolution sum is given by this equation lah. Okay, but what we need to look at is this. Always this equation. This one. Okay, so we have Yn summation of minus infinity to infinity xk hn minus k. So meaning that one of the signal need to be fixed, kan? We have already learned that. Okay, one signal need to be fixed, one signal need to be shifted. So if you see here, this xk is fixed. This one will be the one shifted. Okay, and it can be vice versa. Which one? How do you pick? How do you know which signal to be to be shifted? Okay, as mentioned, always fix the complex signal. Okay, means that if you look at two signals, which signal is more complex? So that signal need to be fixed. More complex, then that signal need to be fixed. The one that you are going to shift is the more simpler signal. Okay, so that's the main idea. Okay, it's same thing for convolution integral. Fix this complex signal. So for convolution sum, you have learned that there are two methods, method 1 and 2. Okay, but I would suggest that always use method 2 for convolution. Okay, either convolution sum or integral. Okay, because it's using the same idea. Okay, you need to draw out and so on. For method 1 is only using equation. So you might actually answer wrongly because there's a lot of numbering and so on. So for convolution sum, it's actually fail proof lah. Okay, normally. Okay, so there is the graphical method. Okay, I don't actually repeat this because you have learned it. So there are four steps. Okay, reflect HK. So means that from HK make it into H minus K, and then you need to shift it H n minus K at n in front and minus K, and then you need to multiply the two sequence at K and H n minus K. Then lastly is that product of the HK with H n minus K is sum over. Okay, so you have done this example. Okay, you have H n and S n. Okay, and between these two signal, most easiest signal is which one? Okay, so example, this is method 1. So I'm going to focus on method 2. Method 2. So between method 1 and method 2, I would say that, oh, it looks like it depends on individual. For me, I look at, oh, okay, I think that the signal xn is much more difficult. So I'm going to fix that. Okay, fix this one. So this one is going to be fixed. This one is going to be shifted. Okay, so how you actually do the numbering over here is just add the value. So you have HK. So then how you write it is that you add H minus K. And then lastly is that whatever value n minus whatever K, value K. So you have, if for this, for example, like this, you have H n minus 2, H n minus 1. Okay, that's why you get like this. So you have n minus 1, n minus 2, and so on. Okay, so after that, you're going to do the convolution. So how you do that is that you need to find first what is the y, the k value when y is equal to 0. So for this example is that we find that the y value at the y is 0 is at k minus 1. So k minus 1. Okay, let's check. So if you have n here, because it's n minus 1, so n, okay, minus 1. So you have minus 1, minus 2, and minus 3. Okay, minus 1, minus 2, minus 3. And let's check with the one that you're going to multiply it with this equation, kan? Okay, so let's look at if it's overlapping. So is minus 1 overlapping over here? No, there's no minus 1 here. There's no minus 2 here. There's no minus 3 here. So therefore, we have the y value is 0. Okay, and next is that you're going to increase the value k lah. So k is equal to 0. So you have n minus n. You have n is 0 lah. And n minus 1. So 0 minus 1, you have minus 1. 0 minus 2, minus 2. Okay, let's look at between this and this xk. Are there any value overlapping? Yes, there is. It's at k at 0 value. Okay, so that's why when you have k equal to 0, okay, 0, how you write it is y0 is k substitute 0 here. So you have the value as x0. X0 is at this point, 0.5. That's why you have 0.5 multiplied by h0. H0 is at this point, you have 1. So you get 0.1. And you're going to repeat it until it starts to have y at 0 again. Okay, from there, you're going to plot out the signal of yn. Okay, so this is what you did, what we did previously. So you plotted everything from y minus 1 until y equal to 4, from 0 until 0 again. Okay, this is 0, 0.5, 2.5, 2.5, 2, and 0. Then you are going to plot yn. So how to check that it's correct? So we have the checking, right? Length of for yn, for the convolution sum, you can check length of xn plus length of hn minus 1. So check, okay, what is the value for length of hn? Just now is 3. So 3, okay? So 3. Length of xn, so we can do a bracket here. Length of xn is 2. 2 plus 3, 5 minus 1, 4. So check again, is it 4? 1, 2, 3, 4. Yes, correct. So basically, the number of k value is correct. Just that maybe you might wrongly multiply this value. Okay. So anyway, when you do the calculation, make sure that you check, double check. Okay. This is what you did on convolution sum, few exercises. Okay, you given this xn and hn. So we did some exercises, right? This one, it was in the video. You can do a recap. And we also did an example midterm. Okay, I think it was not a midterm. Midterm ke final exam, but anyway, same thing. Okay, so and you submitted this as assignment. Okay, I have gone through student assignment. Okay, I didn't get to mark it, but however, I found out that some students have wrong answer. Okay, so let's look at this equation. Okay, I'm going to discuss it. So you have an impulse response h1n delta n plus 2 minus delta n plus hn, and then you have h2 is this value. Okay, carefully sketch h1 and hn over time value. Right. So okay, you actually submit it as exercise in week 6. Okay, remember there's a week 6 there, and then you need to submit. You can check the one that you submit to me lah. Hopefully you have your own copy, kan? So I'm opening one of the student. Okay, this one I checked already. Her answer, I mean Shakira. So her answer is correct. So that's why I'm going to discuss her answer. So for the other student, you can check your own answer. Is it correct or not? Okay. So let's look at this. Okay, you have, oh, tak boleh copy. Okay, you look at this. So you have she right here, H1 and delta. Oh, I mean, this was is not S, delta. Delta n plus 1 minus delta n minus 2. Okay, so when you look at this immediately, it doesn't say that, oh, it's a continuous time or discrete time. Okay, so look at it. Directly, you know that it's a discrete time. So when you plot out this graph, it should be in terms of impulses like this. Okay, so how to okay, how to draw out this? Okay, the first one is that H1. Okay, delta n plus 1 minus delta n plus 2. I think I'm going to wait. I'm open in my whiteboard. Too hard. Discuss it. Okay, so let's look at the first one, A. Okay, so plot H1 and equivalent to delta n plus 2 minus delta n minus 2. Okay, so when you plot that out, you plot it at 0. Okay, look at the equation. Okay, you know that this is delta n plus 2, so it's going to be a pulse. This one also in terms of pulse. And then you have a shifting, time shifting, n plus 2. So n plus 2 is shifting, time shifting to the left, and n minus 1 is, n minus 2 is time shifting to the right. So you know that it's time shifted at minus 2 and 2. This one is at minus 2. This one is at 2. Right? So delta is 1. Since the gain is, there's no value of gain, so it's actually 1. And for the second signal is minus delta. So it means that you have this one at minus delta. So this is for H1. Okay? For H2, okay, is given by what? N, U, N, N plus 4 minus U, N minus 4. Okay? Sorry. Tadi? U. Okay, the whole thing in a bracket, and then you have N. Okay, so when you have that, first of all, you know that, oh, okay, you have this one, time shifting. Okay, and it's a step, unit step. Also this one, unit step, UN. So difference between delta and U is delta is impulse, only one at one value. UN is a series of impulse until infinity. Okay, so that's the difference. So when you look at this, that you know, oh, okay, there's a unit step with a shifting. Okay, so draw that out. I'm going to draw it. Okay, UN plus 4. How does it look like? UN plus 4 is what? Shifted to the left, right? So you have minus 4, minus 3, minus 2, minus 1. Okay, and then it's shifted to the left. So it means that this, until infinity, because it's a unit step. Okay, so this one is UN plus 4. Okay, next signal is UN minus 4. So UN minus 4 is, you have 0 here. See, make sure that you plot it at the same value. So you have 1, 2, 3, 4. Okay, so it's shifted by n minus 4. So n minus 4. Okay, so here, shifted until infinity. So what it means that, okay, if I were to draw this again lah, so that it's the same with the below part. Okay, 1, 2, 3, 4. For example, this is 4. Sorry, it's not a line. Wait, right. Okay, so you see that, oh, okay, you have another signal is that un plus 4 and un minus 4. So here is that you see, oh, there's a substitute over there. So it means that this signal need to substitute the second signal. Okay, first signal, substitute second signal. Okay, so you will get 0, 1, 2, 3, 4, 5. Okay, you have -1, -2, -3, -4. Okay, if you substitute that, of course, you will get this one is 1, this is 1, at this point is all are 0. So 1 minus 0 is 1. 1, 1, 1, 1, 1 until 4, it's 0. At 4, you have 1 minus 1. You have 0. 0, 0, 0, 0. Okay? So you have a value starting from -4 until 3 only. Okay? That one is only for this part. Sorry, this part. Only for this part. Okay? We haven't yet done for this n. Okay? N. What was it just now? N. N is actually for the discrete time. For the continuous time, it represents t. So what is it? It's a RAM. Okay? So RAM. And it's a RAM for t. There's no shifting of that. So RAM for t is that, means that, what? Imagine that this one is the RAM value. Okay? It's at t. So we have 1, 1. So this is the RAM value. Okay? So t. Sorry, t, the n. So you have n value here. So when you multiply this 2, okay, this y minus 2 multiplied by n, okay, you will get 1, 2, 3, minus 1, minus 2, minus 3, minus 4. Just for the sake, I'm going to write there also at the point 0. So at 4, you get 0. At minus 5, also 0. Okay, so if you have here 0, then it's 0. 1 times 0, you have this point. So what you get is this. Minus 4, minus 3, minus 2, minus 1. Sorry, 0, 1, 2, 3. Okay, so this should be the answer for A. Sketch for H1 and H2. Okay, so I noticed that student answer some are wrong. Okay, but for the case of Aimi, okay, Shakira is correct lah. Okay, so this is correct. Okay, the second question is this one. Oh, okay, this one. Assume the two systems are connected in parallel. Okay, so if you remember, this one was actually revision for chapter 1, right? You have a block diagram, you're given H1 and H2, and then it's summation point at S1, at Y1. So it's actually similar to what you learned in odd and even signal, kan? You add two signal or you subtract two signal. Okay, so it's actually a very simple answer here. And you see it's only 2 marks. So it's actually adding this first signal, H1, with H2. Okay, add it up. So when you add it up, at the same value, you have -4 to 3. And also at this point, you have -2 and -1. -2 and, at -2 and 2, you have 1 and -1. So basically, what you will get in the end is, add that up. We're going to use a different color. So at -2 just now, we have +1, right? So you will get -1. And then at 2, you have 2 minus 1, right? So you have 1. Okay? So, which is shown in the correct answer, this one. Okay, you have just now, it was supposed to be at -3 and 2, right? But because you add those two signal together, then you will get this answer, y. Okay, and for the C part is that it asks you to do a convolution. So determine the impulse response for cascade in terms of Y1 and Y2 for the convolution, since it's a linear time invariant system. Okay, so convolve it using convolution. What type? Convolution sum or integral? Since it's a discrete time, then it's going to be convolution sum. Okay, so just do the convolution sum. Okay, this one will be the final answer, the correct answer. Okay, so for those who didn't answer correctly, okay, if you are in front of your computer, just screenshot this, then try to do it again. Okay, and you get the answer. For this case is that I think Aimee is using, I'm not sure, she's using what? She's using equation method 1. But anyway, try to use method 2. Okay, method 1, if you write like this, I'm not sure how you get this answer because it doesn't show any value. Okay, you just put n plus 1, u, n plus d, blah, 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 but there's no value. Remember, if you were to use method 1, use it correctly. Okay, you need to write out the value like this. Okay, maksudnya, insert the value. Okay, so you have y1, 0.5, and so on. You add it together. Then only it's correct. If not that, if you don't substitute the value, then I do not know if you copy from your friend. So make sure that you substitute. Without the steps, okay, you didn't do convolution, the graphical method. Without that steps, your marks might not get full marks. You might get the n graph correct, but you're missing the marks in the step value here. Okay, if you see here, there's only one equation answering this. So if you did it correctly, you should have for each point y minus 1, y minus 5, y minus 6, y minus 3, y minus 2, y minus 1, y 0, and so on. You will get an equation and you are going to plot that. Okay, this one only 1 marks and this is 1 marks, maybe out of 10 marks. So you only get 2 over 10. Okay, answer is correct, but you won't get full marks. Okay, right, so hopefully all students understood that. Okay, so that one was the example. Okay, and then we have the convolution integral. Okay, convolution integral is the same, just that you have only the method, graphical method. So I would suggest make sure either way, if it's convolution sum or integral, just use the graphical method. Okay, so you did exercise of this example 3 previously. Okay, you do the shifting the equation for the convolution is this one. Yeah, it's going to be integration. Okay, so you're going to integrate it. Okay, non-overlapping value. Okay, shift it. Find first the non-overlapping value at y equal to 0. What is the value t here? And then you're going to overlap it. Okay, draw out the graphical method, shift it up until it gets 0, then plot the graph for yt and get the equation. Okay, quick check is length. Quick check for convolution integral and sum is not the same. Quick check for integral is that you don't have the -1 at the end. So you have length xt plus length ht only. So 1 plus 1, 2. Right? Then you did the revision for this example also. So we have xt and ht. It looks the same, but it's not the same. You have this one for 0 to 1, and you have another one is from 0 to 2. Okay. So it looks like this. Okay, you already did this example. Then you plot the value for yt. Okay, and then you can check it. Okay, this one was one of the tasks that you need to submit. And also we did on the another example of convolution integral. Okay, you have a value 1 for 1, 0 to t, and you have 2 at 0 to t, and between 2 to 2t is you have 3. Okay, this one you did in the exercises in submission. And lastly is that when you have equation where you have one is a simple question and one is that is a equation that you have a RAM value. So this is a bit difficult but doable. Okay, so you just need to remember that for the integration of a constant, how do you integrate it? Integration for a variable, how do you integrate it? So for constant value, if you have one, then it's going to be a dx, so you get x only. A is a value, so if it's a, then you have ax lah, okay? And variable x dx, so you have x squared over 2. And for squared x2, you have x power of 3 over 3. Okay? So similarly, how you do it is that you are going to find out first what is the value for y equal to 0. Means that what is the t value. Okay, find that and then start doing the integration. Okay, okay, and then lastly is to plot it. Okay, do integration and plot it, and you will get the equation. Okay, any question? Of course, this one is in this as revision is that only a few example. Okay, I recap. But if you go through again for chapter 1 and chapter 2 classes, we did some revision where the integration is multiple types of question. For example, let me see. Okay, let me see like this. Okay, this. Can you submit this? Okay, I think we did this exercise, right? Guys, you did this exercise and you submitted, right? Okay, so when you do integration for this, means that at some point, okay, if you look at this, okay, if you were to shift this and then at one point, you will have the equation looking like this. Okay, means that is going to be overlapping like this. So this value is at 2, this one is at 3. Means that when you do the convolution, so you want to find what is y, e, okay? So So what you're going to do is that, for example, you did some shifting already. So for this case is that you see that, oh, okay, between 0 to 1, the value is changing. And this one is at 2, this is at 3. Means that you're going to have two different integration, which is summation point. Yeah? So you have from 0 until 1, you have one value here. So 1 times 2, okay, dt, plus 1 to 2, 1 to 2. You have 1 here, 1 times 3, okay, dt. So remember that if it doesn't have the same value, then you need to have multiple integration like this. Okay, you cannot sum it up because the amplitude is different. Okay, unless if it was like this, it was this ramp signal. Okay, this ramp signal, because you already defined that this equation ramp is 1 over 3t. So it doesn't care if you shift it. So you still are using this equation. So that's why it's only integrate only one term only. Okay, so there's a difference between this exercise, even though it doesn't have the same amplitude, okay, because it's a ramp. But for the case of this, okay, it have a different constant amplitude value. So you have 2 and 3. So you need to differentiate it like this. Okay. So I think that's all for the revision. We're already at 9:50. Okay. Because some student commented, okay, I read your comment. So commented that they have class at 10. So please, can we finish it on time? So I think that's all. So just a recap is that midterm, again, midterm is at 25 May, Tuesday. Make sure that you come. Do not give excuses that you didn't wake up, you have fever. Sorry, but if you have fever, please make sure that from now, take care of your health. Eat and drink, take care of health, eat better, don't eat junk food, and so on. Okay, so because why? If retest is only given if you have MC from government hospital, okay, government hospital only. But bear in mind that the exam will be twice or triple time difficult. Okay, it will not be the same as what the other students have gone through because you already seen the question, so it's going to be totally different. So you might as well sit with your other friends. Okay, so any question? If no question, any question? No, guys. Okay, tak berbunyi, tak ada question lah kan? Okay, no question. Go to reflection. Okay, for the reflection is that then already open. You can go and do the reflection. Oh, week 9 okay, week 9. So answer that. So as usual, right there what you have learned today. Okay, in here is that I ask, please be true to yourself. So for midterm exam next week, I have done the following to ensure good grades. Okay, I've revised slide chapter 1 and 2. Leave slide and slide. Go through all slide. Second, I have revisited the recording video of synchronous class. If you don't lah. If you did that, then just click that. Okay. And then I have done all the exercise and tutorial given. If you have done all, then click. If no, don't click. I have made my own notes and summarized it into my map. Excellent. This one should be excellent effort lah. Okay. So based on this, you should able to estimate what you will get for midterm. Is it more than 80% or less? Less than 80 because you didn't do all of this, then put effort lah. Okay. And are you aware that the date and time? Okay, just select which one do you think is the exam time. All right, that's all. Thank you very much. I don't think there's any more questions since all are a bit quiet. So I think that's all. Thank you. Assalamualaikum warahmatullahi wabarakatuh. Bye.
Doktor.
Okay, bye. Sama-sama.